All right, let's talk about code design. Once you're to this point, basically the whole system is mapped out in your head and you're going to start building code towards it. Once you start coding, you're always going to find things you need to change about the other design work you've already done. But at this point, you should have a pretty fair understanding of what you're trying to build and how you're going to get there. So your code now should either, if you're doing a monolith, then you're going to start just making code, or if you have microservices, then you're going to start organizing those microservices to interact with the data they're responsible for. One of the first things you need to think about is what coding language you're going to use. And if you have microservices, different services can use different languages. You don't have to use the same language for everything. A good example might be if you have like an encryption service that's doing some really heavy low-level stuff. Maybe you want to use something that's better at low-level stuff. Maybe you want to use Golang or something. Or maybe you just want to pick something that everyone's familiar with. It's smart, and I mentioned this in the last video, it's smart to pick a stack or a tool set that everyone is familiar with and just really lean into it. Everyone knows how to use it already. You're not going to have people wasting cycles trying to learn a new language, et cetera, et cetera. It can be fun to learn a new language, and it can be cool to use different languages for different things. But if you really lean into a core tool set that everybody's familiar with in all of the use cases that it works for, you can move a lot quicker and everyone can just jump in and help out, right? If you have 6 different programming languages and 6 different services, and then you hire a new person and they don't know those languages, they're going to have a long ramp up time trying to figure out what's going on and learn the different languages. So employee familiarity is a big one. Performance in specific use cases, we kind of talked about that. If you're using like some low level stuff, maybe you use a language that's really good at that. Some languages are just easier to use, especially if you're okay using like third-party libraries. Node.js has a ton. And I know that every language is kind of doing that now. Maybe not every language, but there are some. Like C# has nuggets, or whatever they're called. But at some level, if there's a language that's just really easy to use, it can be worth it to just pick it and go with it. Especially because if you have some really good third-party libraries, you can spin things up really fast and get code out the door. And then the last thing to maybe think about with picking your coding language or framework is community support. Excuse me. If you're using bleeding edge technology and then you run into a bug or an issue, it can be really hard to find answers online for, if nobody else has seen it before, you're not going to find articles to help you through it. Whereas if it's something where there's a ton of community support and it's used everywhere, then that might be a reason you decide to go with a specific framework or language or something. Start to think about if you want to have stateful or stateless servers. 10, 20 years ago, it was really common to have stateful servers, meaning your server is keeping track of data specific to a user's session. The problem with that is every time the user sends a request in, it has to be to that same server because that server is keeping track of their session data. Unless you want to like pull session data out into like a Redis cache, which you can do, but then the server itself isn't stateful anymore. You see what I'm saying? If the server itself is keeping track of data for a user's session, then the user has to interact with a specific server, which means you can't really do load balancing. If you need to scale horizontally and have 5 different servers or 10 different servers with the load balancer always has to send the same user to the same server. And you can kind of hack your way through that if you use sticky sessions. But it is a hack, and going stateless makes load balancing a lot easier. Now, if you're using some kind of sockets, that is the server is keeping track of an open connection to a specific user. So if you're going to have stateless servers, then instead of sockets, you need to do something like you could use a pub sub model, or you could use long polling, which is where the client just, maybe every 30 seconds makes a request to see if what they want is there yet. So that's how you can replace sockets if you decide to use stateless architecture. Caching, if you have a stateful server, you can just cache in memory. If not, then you have to pull caching out into like a Redis cache or some third-party caching where all of your server nodes can talk to the same cache, even though they all live behind a load balancer. They're all running the same code, so they all need to act the same. So they all need to talk to the same cache. Hope that makes sense. What API protocol are you going to use? REST is very common. XML is kind of older, but I've seen it used once or twice. GraphQL is newer. I personally am not a fan. I know there's a lot of people that love it, and there's some cool aspects to GraphQL, but I think it's a lot of times used poorly and it invites really bad patterns. That's just my opinion. Maybe that'll get better as it becomes more, as people use it more and learn better ways to use it. I don't know. One thing to think about with your code is organizing it into code layers. That makes your code really easy to think about and really logical. And I'll show you an example over here in a second. This is a huge thing I like to do. I really like having defined layers in the code, and the different layers can talk to each other. But it helps make your code more modular, and it provides a really logical way to organize your folder and file structure. So you can also think about like at a functional level, if you're going to use something like dependency injection, so that instead of a function having some things baked in, you pass in the dependencies it needs, and then it can do these really generic things. If your code base is small and you're just getting started, some of these patterns you don't really need them. So some of this stuff, you don't really need, and you can kind of skip it, and you can add it in later if needed. And this is one example of code design patterns. You can look up code design patterns, and there's a ton of them, and there's tons of different things you can do. Object-oriented programming is another one. I don't even know them all, if I'm being honest. But this is one that I've used that has some benefits, so I popped it in here to look cool, I guess. Testing. It's important to think about testing if you're going to have automated testing. You can have unit tests, which is where you're testing a specific function to make sure it does what it should. You can have integrated tests, which is, in my mind, more like you're testing an endpoint, and that endpoint has a trickle effect of different functions and methods that it calls, and then you're testing the endpoint to make sure it does what it should. You can have end-to-end tests, which is like if you have some kind of UI testing software like Selenium, it can spin up your actual application on the front end and like interact with it and make sure everything works like it's supposed to. That could be pretty cool, especially for like automated smoker regression tests if you're doing deploys. Specific to like unit and integration tests, you can decide as a team, do we want tests? Are tests required? Are they encouraged? Do we not want tests? Should we stay away from them? All that kind of stuff. Clean code. I'm a huge fan of clean code. It's important for the team to feel like they're at home though. So you want to come to decisions as a team that everybody's comfortable with. But in my opinion, clean code is awesome. If everybody's code kind of looks the same, it makes it easy for anybody to jump in any part of the app and figure out what's going on, which is awesome. It makes it easy for people to get up to speed quickly because all the code looks the same everywhere. And so I'm not just talking about formatting, which that's one of them, right? Like, are you going to use a formatter like Prettier or something? But, formatting is important, but there's other things too, like having well-named variables and functions. If you can just read through the code and understand what it's doing, that's awesome. But if the variable names are weird or like, just a single letter, it makes it really hard to keep track of what's going on in your head. Small functions that are easy to read, maintain, and test is important. And then if they're well-named and they're small, it's easy to read through the code and see what's going on. It's awesome. It's important to abstract and encapsulate logic when you can. So if you have 8 different places that are all trying to validate the format of an email, maybe you just write one util function that validates the format of an email. You can have good testing around it, and then those 8 places can tie into that one place. The logic is abstracted, meaning all these different places don't have to worry about regex and how to do it. They just tie into this one function that encapsulates the logic. It's well tested, it works, and everywhere else can tie into it. This can be especially true if you're using like a third-party library. It can be, rather than all the different places in the code accessing it directly, this is just one option, but maybe you have a library wrapper so that all the places in your code tie into this one place that you've written that interacts with this library. But then if you want to change that library out down the road, you're just changing one file. There's a couple functions, you change them, you're done. It's easy to move on. So these are some different things to think about and talk about with the team. And then I'm going to go over how I like to architect code. So you have your root level with all your different things. And of course, I've used PHP, I've dabbled in Golang and C Sharp, but for the most part, I really like Node.js. I'm a Node developer. Excuse me. I would recommend always using TypeScript with Node. It really helps so much once you get used to it. So this is a common way that I would organize and that I have organized my projects. You have all your root level stuff, and then your code is in a folder. Inside of the code, I'm organized by data layer. So you have your entry points. That's like any way that you can get in and interact with the code. So you have your endpoints. I've called it controllers. I think this is a pattern that maybe is familiar to people that have used C# is to call it controllers. You could call it endpoints or routes or whatever you want. But there's other ways to talk to the code. You can have scripts that you run. That's an entry point into the code. You can have cron jobs that run regularly. That's an entry point into the code. All of these entry points, they need different permission checks, really. Your controllers probably do. Your crons and scripts, I don't know, you can think about it and figure out if they need permission checks. But ideally, your permission checks will live in your entry point layer, because this way all of your different entry points can tie into the same business logic without having permission checks that it works great for an endpoint, but then for your script that you're trying to run, it fails because of a permission check or something. So it's good to have your permission checks belong in the entry point layer, and you can even separate that and have like an entry point layer and a permission check layer, however you want to do it. But I think the business logic should live after both of those things. So this is maybe your entry point layer, and you have some different controllers. And this is an example of a project that I have worked on recently, but it's not this e-commerce site. So I'm using it as the demo, but you'll notice the controller names are a little bit different. This was more of an Etsy clone I was doing, which is similar in a way, but you have like your user and your shop and your products and a couple different things. So anyways, so if you see some file names that don't make sense for our example, that's why. But so you have your entry point layer, and then you have I'm using Express. So I have a middleware folder for middleware stuff. And then you have your business logic layer. So once the authentication and authorization is done, then your entry points call into business logic, and your business logic is that's the beefy part of your code. In my opinion, that should be like where most of the meat lives. And so you can separate your business logic into more finer grained layers if you want, but this is where all of the logic happens. So an example would be, if I'm signing up to the app, should I be able to use any email address that I want? Because what if I'm trying to use your email address and you've already signed up? So maybe we want to have unique email addresses in the system, which is a common thing. And that's business logic though. Maybe you don't want that, who knows, but it belongs in the business logic layer, where if I'm trying to sign up, it'll check and say that email's already in use or something. So the business logic layer has all of the business logic, and I've called it services, and then that interacts with a data layer, and the data layer that's all it is. It interacts with your data. So the actual files that interact with it, I've called repositories or repos. You can call it whatever you want, but this, and this is using TypeORM, but this is just interacting with the database. This will create a user record. So anytime I want to create a user record from somewhere else in the code, I can say, hey, data layer, create user, and it'll do it. And I'm getting some errors because I haven't installed the dependencies here, but besides the functions that interact with the data, I'm using TypeORM, so I also have an entities folder where I'm defining what the table looks like. This also defines a TypeScript type, if you're not familiar with TypeORM, but I'm defining a TypeScript type, and also I have these decorators that say, hey, actually create a column as well, and I'm using UUIDs for the ID, so that's why it's something like that. And then you also have a utility layer, which is just like helper functions, any kind of stuff that they have zero dependencies. They're not interacting with data. It's just a function that knows how to do some stuff. So if you have tests, you could have a tests folder. I have TypeScript types inside of a types folder. So that's one way to organize the code. And then also with the data layers. So that's an example of how I have laid out some personal projects. And that is it for this one.